this is Jo from Maths Tutor Me. Today we are doing factors, multiples and indices, and we've come to the end of our topic. So we're doing some revision today. So I have a few questions for you. If you're feeling pretty confident with this topic, you can pause the video, try all these questions and then restart to see all the answers. Or if you still think you need a little bit of extra help, you could just work along and do these questions with me as we go. All right, so for question 1, we want to find the first two common multiples of 4 and 10. Okay, so multiples are like times tables. We want to do 4 times tables. 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12, 4 times 4 is 16, 4 times 5 is 20, and we keep going, keeping adding on 4 as we go. 24, 28, 32, 36, 40, okay, and let's go to 10 and do some 10 times tables. 10, 20, 30, 40, and maybe you've noticed, because I have, that we have some common multiples in there already. So 20 is in both of them, and 40. Okay, so the first two common multiples are 20 and 40. Question 2, find the highest common factor of 54 and 90. So let's list our factors. For 54, 54 could be 1 times 54. It could be 2 times 27. Okay, then we try 3. Is 3 a factor? Yes, it is. 3 times is with 18. 4, no, that's not going to divide by 4. 5, it's not going to divide by 5. But 6 is going to work. 6 times 9. 7, no. 8, no. And then we've reached across to 9. All right, so that's all the factors of 54. Let's try the factors of 90. 90 is 1 times 90. It could be 2 times 45. Yeah, 3 times 30 makes 90. 4 is not going to work. 5 times by 18. 6, yes, 6 is going to work. So 6 times by 15. Oh, getting a bit squishy in there. And 7, no. 8 is not going to work, no. But 9 times 10. So quite a lot of factors there for 90. So starting, because we want the highest common factor, let's start with the high numbers and see if 54 is in here. No, it's not. 27 isn't either. 18 is. So there is the highest common factor, which we can call HCF, is equal to 18. Question 3, we want to write this in index notation. So 5 is times together twice, that's 5 squared, times by 3, there's 1, 2, 3, 4, so 3 to the power of 4, and just 1 7, so times 7. Question 4, we want to do the opposite. We have index notation and we need to put it in expanded form. So 2 is the base and there is 4 of them. 2 times 2 times 2 times 2. Then we have 7 multiplied 3 times. 7 times 7 times 7. Question 5, we want to know, is 14,144 divisible by 8? So if you were with me for my earlier lessons, we know that we have a divisibility test for 8. It's if the last 3 digits are divisible by 8, then the whole number will be divisible by 8. So let's take those last 3 digits, 144, and see if we can divide that by 8. Well, 1 we can't divide by 8, so let's take 14 divided by 8 would go once, and we have a remainder of 6. 64 divided by 8 is 8, because 8 eighths are 64. So that went exactly, and there was no remainder. So that means that yes, this number is divisible by 8 because the last 3 digits was divisible by 8. Question 6, list all the prime numbers between 20 and 30. Again, in the lesson that we did on prime numbers, we learned about a sieve that showed us all the prime numbers. And if you remember that sieve, hopefully you'll realize that the numbers 23 and 29 are the only 2 prime numbers between 20 and 30. On this next page, we have a few more questions. Question 7 is some calculator practice. It says use the calculator to find 34 to the power of 2, or 34 squared. So in the calculator, we type in 34 squared button equals 1156. Okay, and the next one, 7 to the power of 3. 7, that button there for power of 3, is equal to 343. And this is a square root question, so the square root button is just there. Square root of 529 is equal to 23. And question 8, use factor trees to put 50 and 140 in index notation, hence find the lowest common multiple. All right, well, for 50, okay, that's easily broken down to be 5 times 10. 5 is a prime number, so that's finished. 10 could be 2 times 5, and they are both prime. So that tree is finished, and we can write 50 as 2 times by 5 squared in index notation. 1, 2, and 5 squared. Let's do it again for 140. Let's divide that by 10 again and get 14 times 10 as my first branch there. Both of those are composite, so I need to keep going. That could be 2 times 7. They're both prime. And 10 could be 2 times 5, and they're both prime. So that tree is now finished, and 140 can be written as 2 squared times 5 times 7. So all these circled numbers multiplied together. Now to find the lowest common multiple. So we look at our prime factors in here. Our lowest common multiple is going to be the highest powered factor from each one. So 2 or 2 squared. 2 squared is bigger, so let's do that one. 5 squared or 5. 5 squared is bigger. We do that one. And this one doesn't even have a 7, so this one's going to be bigger. 7. If we times those together, we get our lowest common multiple, which is 700. Okay, that's the end of our little revision lesson today. I have a few challenge questions, just a couple for those of you who really want to challenge themselves. If you think you've really mastered this topic, then join me next time for those. Bye for now.